I think it's wrong somewhere, but it's not wrong on my things. Okay, just on this problem, I got a few questions on this problem, so I want to bring it back up. I didn't have it incorrect in class. I don't like to think about my feet, but what they were doing is on Excel, they were using e to the 0.06 as their b. So you would have to actually transfer, this is the correct answer, someone actually typed that into Webassign and it took it. So apparently you were able to just type it directly in. However, Webassign said they wanted it in the form of y equals a times b to the x. What you'd have to do, the a is there, and you can actually click on that and tell it to round it to 2 decimals for you. We can be lazy. It's okay. You know, some older people get really upset about this. I guess I'm one of those older people, so it's maybe my generation get really upset about this. But, you know, we're thinking about other things now, like what's the meaning of growth charts. So we're not sitting there and rounding things by hand anymore because a computer can do that. So to me, it makes sense to do it this way. Go ahead, tell it to round for you, especially because Webassign wants the correct exact answer in there. Might as well get it correct with a computer. This part, though, is the b. b is equal to e raised to the 0.06. Recall that e is 2.717, so you take that number e and raise it to the 0.06. And I got 1.09 on this question. So the Webassign answer was 36.82 times 1.9 to the t. So that's what they wanted. Is that clear? Good. We're actually going to do the take-home point a little bit more in here. You're going to explore with that a little bit more.
What does the T stand for?
Nothing. It's was this? Yeah, this was a nothing, wasn't it? This was just a made-up problem, or was that a bacteria problem? It's a bacteria problem, right? So the T stands for time in that case. Now, I generally, if I have to make up a function, I usually put T at the x-axis because that's what you usually see. Not always. I can give you an example where it's not always, but it usually is time. Okay, so on the in-class assignment so far, we have done a little bit where you looked at that curve and looked at different points in that curve, right? And said, okay, here it's going fast, here it's going slow. So you do understand that you're going to be actually looking at how fast it's going in certain portions. You can actually graph a line right there. That's what you're really doing. You're approximating the curve by a line right around that point. And we're going to physically do that in class just for fun on those growth curves so you can see that. But what if you have a formula? Y equals 3x squared plus 2x. Never happens. Never happens. No one ever gives me a formula like that and says do something with it. But let's suppose, let's pretend that you get a formula like that. What do you do then? How can you find the tangent line then? What I see in the biological examples is mostly data. So I think that we should work with mostly data. But let's pretend. Let's pretend a surgeon comes to you and says, I have this curve. Y equals 8x minus x squared. Never has happened to me yet. How do I find, this line is called the tangent line, and the slope of that tangent line matches that curve. It's the line, so they're growing at the same rate right at that point. So right here, you see fast growth, here's fast growth, but over there at the top, it'll slow down if I drew it again there. So you get a different looking line based on where you are. We're going to do that again in here with the growth curve, so it'll make more sense. But how do you find the equation of that line? A lot of calculus classes spend, if you're going to the regular Calc one, they'll spend hours just calculating tangent lines. Good for them, right? But how do you find that? Here's the Webassign problem. Y equals 8x minus x squared, given to me by a surgeon. Ask me how do I find the slope of the tangent line at that point. The point they gave me is x equals 1. Can you see that? The point, x equals 1, and they gave me the y value. But I'm going to show you how to get the y value in a second so that it makes sense. And they want some stuff. They want the equation of that line. So back up a bit, they want the equation of that red line. And that is exactly the curve the surgeon gave me. All right, so here's my curve. That's where I start out with. The point I'm interested in is x equals 1. Where does the 7 come from? The 7 comes from plugging in the formula, 8x minus x squared. I plug 1 in there, and guess what? Y equals 7 comes out. So here's the trick. It's exactly what you would think to do. Pretend this was a growth curve. If you're interested right at that point, you would just take 2 points close by each other around that point and then connect the dots. And look at how fast it's growing in between those 2 dots. You do this all the time when you estimate how long it's going to take you to drive somewhere. You make 2 dots. One is the end point, one is the beginning point. And you estimate you're going about 60 miles an hour, right? So you make some estimations like this. So we're doing some estimate like that. And I'm just going to pick an arbitrary point to the right. So I could go out 0.01 to the right, I could go out 0.10 to the right, I could just go just a little bit to the right of my interesting 0.1. Get it so far? Thumbs up? Okay. So I'm just going to call it A because what I'm going to do is I'm going to move that A. Think of that A as a slider. I'm just going to move that A around. So that's my intent. But I go out to the little bit to the right, and I'm going to draw a line to those 2 points. That's called the secant line. And I know how to find the slope of a line once I have 2 points. That's the stuff that you've been doing forever. You were just getting ready for this one day today. The whole math that you were doing was for today. You take the line y2 minus y1, x2 minus x1. And in fact, I remember in pre-calc, they had these weird problems sometimes where they gave you an f of x, and they made you do the y2 minus y1 and with that a inside it. Remember that? Good. Because if you didn't, you'd have to say you had Dr. Song for a professor. Remember that? Yes. She had me, so she has to say yes to all those questions. Okay, so what's my y1? It's f at 1, which is 7. What's my x1? It's 1. Those are my 2 points. This one to the right, this one right here. The coordinates, this is my x1 and this is my y1. What about my other one, my y2? Well, my x2 is a, just to the right. How do I get f at x2? How do I get my y2? Plug in a into the formula. So y2 is 8a minus a squared. I don't know what the y2 is exactly because I'm going to fool around with the a and start scooting around everywhere. So I'm just leaving it. I'm doing the woman thing. I'm leaving I'm hedging my bets here. I'm just going to leave the a. I don't want to decide. And then I just plug it into the formula. y2 minus y1 over x2 minus x1. Plug everything where they're supposed to go. You see it? You see it? Who's asleep? Raise your hand if you're asleep. Okay. It's warm in here, so I do understand if you're sleeping. Okay, so now I do some algebra. I'm not going to go too much into the algebra. You can go look at the directions here. So all I did is I copied and pasted this y2 minus y1 over x2 minus x1 because I copied and pasted it up there, and I pulled out a minus sign. Why is this correct? Minus times minus gives me 8a. Minus times this gives me minus a squared. Minus times plus 7 gives me minus 7. So I just factored out a minus sign. That's all I did on the top. And then I canceled these 2 minus signs around. If you're going to make a mistake, it's going to be a minus sign mistake. A lot of minus signs floating around. So this is what I did, is factored out the minus sign, and then I'm going to cancel these minus signs out. So I get that below. This is just high school algebra, but without rhyme or reason. I'm going somewhere with this, I promise. So now I'm at the very top. Okay, I have this guy up here. Minus signs have been canceled. I'm here. And I factor. And when I factor, I get this a minus 1 on top and the 1 minus a on bottom. Those two things are negatives of each other. They cancel. And I get minus a minus 7. What's the question? How did I know that? I know that somebody wants to ask that. So I'm asking it for you. Why does a minus 1 over 1 minus a equal minus 1? Well, because I can factor out the minus 1 on the 1 minus a. 1 minus a with a minus 1 on the outside is the same thing as a minus 1. So that's why they cancel out and I get a minus sign as an answer. Somebody wanted to ask that because I'm moving really fast. And I know that. I can read minds. I'm not wearing the same sweater as I wore. I can read minds. I think I'm not. Mathematicians tend to wear the same clothes every day, so it might be true. So I get minus 1 as my result. And this whole mess turned out to be just 7 minus a after all the cancellations are done. It is true about the clothes wearing thing. I've thought it before. I thought, well, I wore this to class yesterday, but I'm not going to see them today. So why should I have to pick out anything new? Just wear the same clothes again. They weren't dirty. It's not like I was running marathons in it or something. I do have a problem if someone's wearing the same clothes for 4 years. I've seen that. Okay, now I'm going to do a little trick. If I got the second point right over here, the second point that I chose here, there's going to be some error when I put that line through those two points compared to the tangent line. They're not going to be perfectly the same. They're almost the same. But what if I scooted A just a little closer to 1? Would the error get less or more? If I scooted the A down, closer to 1. Those of you who are sleeping, would it get better or worse? Error. You got a 50-50 chance here. Better, right? Because you're going to get closer to being the tangent line if you scoot the A down on 1. So picture that A moving. See? It moved. Did everybody see it move? Moved a nicely moved, right? It's just scooting closer and closer to 1, and my slope between those 2 points is going to look like the slope of that point A equals 1, and I can really just plug in A equals 1 if I want to know what's happening, because when A is scooting down to 1, 7 minus A is getting closer and closer to 1. What's that slope getting closer to? Louder? There we go. 6, right. So we have a slope of 6, and that's how you get the slope. That idea of scooting is called taking a limit. That's called taking a limit. That's why you take limits. The chapters in your book are set up so that the first section is taking limits, and the second section is the punchline. This is the punchline. So we're reversing the order. I'm telling you the why. This is why you're taking limits, so that we don't do the whole section on taking limits first and then do this.
I'm a little confused. What is the point of this? Like you're scooting things around.
Right. So the whole problem was.
Because like you already know that point, right? That 1 to 7. So why are you?
Because it's not good. It's not the exact answer, right? It's just an approximation. So if I drew the line between those 2 points, let me see if I can put a line between those 2 points. If I put a line between those 2 points right here, let me make it dark. See that line between those 2 points? It's not exactly the tangent line, it's an approximation, right? You agree?
Yeah.
All right, so how do I get it exact? Well, the closer I scoot that A to 1, the better it's going to be. The closer I scoot the second arbitrary point down to 1, the closer it's going to be to being the tangent line. So I'll show you the same thing on the actual graph so you can see it. That guy's a tangent line, the red one. The point that I took was this one. Let me scoot it up a little bit. So I'm exaggerating it a bit, but so if I took it out at 1 and I connected 2 dots on the curve, it's not exactly. I'm exaggerating. So right, if I took just 2 points, that secant line, that first black line is not exactly the slope of this line. But if I make the second point closer, it gets closer. And the closer I make that second point, the more it's going to tilt up and be exactly that same tangent line as I'm sliding it. There's animations online that are really cool, that are much cooler than what I just did here. This probably wasn't very cool at all, but yeah, it's like pretty crude. That's another dangerous thing about mathematicians. They think they're cool, but they're not. I know. Okay, so I have slope equal m equals 6, and I got it from that scooting method. We don't call it scooting, we call it taking the limit. That's a formal way of saying it. How do we get the whole line? That's what you're supposed to get. You're supposed to get y equals mx plus b. We got the m. How do you get the b? Well, we got a point and slope. Remember those problems? Yeah, point and slope. What do you do next? From multiple repetitions over the years, you use that formula, y minus y1 is m times x minus x1. Your x1 is 1, your y1 is 7, plug and chug. And there's your formula. I actually have to be honest, I have used this for a formula before, but none of the surgeons knew this or asked me this. I came across doing this myself, so it's not like they invented something and asked me, hey, here's a function, find the tangent line at this point. Nobody ever asked me something like that. Okay, so I can check my work, right? I can just plot the line that I came up with and the curve that I'm supposed to plot on the same graph, and it should look right. And it does. On the quiz, when you get a question like this, you're going to have to explain first what you're doing. You can't just go through the motions and say, I'm chugging here and chugging there. I really want you to, this is the point. This is what you're doing. All the formulas that you get after this, as bio students, you will never see them again unless you go into some bioinformatics or some math program that's combining biology and math. And by that time, you'll know what you're doing enough to know that that's what you're supposed to do. What you're going to get is data. And what you're going to do is actually make approximations, which was her point. So why isn't it just good enough to take those 2 points and just cross? Right, Bella? Not sleeping, are you? Wake up, I'm talking to you. So what she said was, why isn't it good enough? It is usually good enough because you usually don't have anything but data to begin with. So if it doesn't look right, don't stress because you have a quiz and it's timed and blah, blah, blah. Actually say so. I did all the work. I put them on the same graph. Doesn't look right. It doesn't look right. So say it. It doesn't look right. It's supposed to look this way. So here's my point why that should count for something. It should count for a lot more. Who do you think understands more? Someone who goes through the motions and does all the mechanics correctly and gives you the final answer and it's correct, or someone who graphed everything, did all the motions, made an error somewhere, plotted them, and knew they were incorrect? Probably the first person I have to say, I don't know. Maybe they do, maybe they don't, right? They haven't given me enough information for me. I haven't asked them enough. But the second person, I know they really know what they're doing because they know the end point was to get this line that is perfectly a tangent line at that point. And I would hope to God that you're in this class, you know how to find the equation of a line. So you made some stupid error somewhere, and that can happen. So that's why I give nearly full points if you go through the motions and get to the end and find out that you don't have the right answer. But you'll also be asked to do that last piece to make sure you have the right answer or not. Questions? Okay, I got to ask you again because this was really, really important. I reversed the order of things. I need to know if you got it. Montclair State Internet. I need to know that you at least understood me or feel comfortable with this so that when you go back and look at it on the video for the second time, that you understand what's going on. At least nobody's putting D. You sounded like the adult on Charlie Brown. Okay.